Next, multiplication of vectors. In this multiplication of vectors, a vector multiplied by another vector may be give a scalar or vector. When one vector is multiplied with another vector, then will give either vector will give, otherwise scalar also will give that. Hence, there are two types of the product of for multiplication of two vectors. Here I have the two types of multiplication, that is, one is the dot product or scalar product. First one is dot product. This another name is called as a scalar product also. Next, second one is cross product, or another name is called as a vector product. Here first one is dot product or scalar product. For that is scalar product or dot product. The scalar product of two vectors, its statement generally it is the scalar product of two vectors a bar and b bar is given by a bar dot b bar equal to ab cos theta. Generally it is having the statement also. Generally how to write the statement mean the dot product of any two vectors equal to the dot product of any two vectors is equal to the product of magnitude of their vectors and cosine angle in between them. For example, here a bar and b bar are two vectors. Here a bar is the one vector and b bar is the another vector. So dot product means taken as a dot only, a bar dot b bar, that is equal to dot product of any two vectors. Here two vectors were taken, a bar is the one vector taken, another vector is b bar taken. Its a dot product equal to the product of magnitude of their vectors, magnitude of vector a and magnitude of vector b and cosine angle in between them. It is only the statement about dot product. Here the scalar product of two vectors a bar and b bar is given by a bar dot b bar equal to modulus of a bar and modulus of b bar cos theta, that is equal to ab cos theta also can write, where theta is theta is angle between a bar and b bar. Here a cos theta is component of a bar along b bar and b cos theta is component of b bar along a bar. The dot product of two vectors is a scalar only always. Dot product of two vectors always will give magnitude only, that is not will give any specific direction. So here these points once observe. Here a bar is the one vector and it is a b bar vector. Angle between the vectors is theta. Two vectors taken here, one vector name is a bar and another vector name is b bar. Angle between the vectors are theta. Now component of a bar can take along the b bar direction or component of b bar can take along the a bar direction also. Here component of a bar along b bar is can take a cos theta, or component of b bar along a bar also can take along the a bar direction b cos theta. The component of a bar along the b bar and magnitude of b will give dot product of the a and b. We will see that a cos theta into b, ab cos theta, or a into b cos theta, ab cos theta. Either component of b along the a bar can take or component of a along the b bar can take, its product will give as a dot product of the two vectors. Properties of scalar product. Scalar product is obey the commutative law. Obey commutative law. Commutative law have an idea. Here a bar dot b bar equal to b bar dot a bar. Dot product of a bar dot b bar, what is the value getting? By b bar dot a bar also will get same value only. Scalar product is obey the distributive law. Obey distributive law, that is a bar dot b bar plus c bar equal to a bar dot b bar plus a bar dot c bar. Just you divide the terms only that. but it's the product what is giving the value, this product plus this product also resultant value is same that, so it will be obey that. Next, scalar product does not obey associative law. Here associative law means a bar dot b bar dot c bar is not equal to a bar dot b bar dot c bar. It is does not obey this value and this value both are not equal, so it is does not obey that. Next, scalar product of two parallel vectors is maximum. A bar dot b bar equal to ab cos theta, theta value is 0, parallel means theta value 0 it is. The value of cos function is maximum, then cos 0 value 1. So, dot product of vectors when both are parallel, it is maximum will give. The scalar product of two opposite vectors is negative and minimum. Here theta equal to 180, opposite vectors means angle between the vectors equal to 180. So, here take a bar dot b bar equal to ab cos theta, theta plus write 180, here theta plus take as a 180, then cos 180 value is minus 1 into ab. So, here take minus ab, that is. Next, scalar product of two perpendicular vectors is 0. Perpendicular vectors means theta value is 90, that is. So, the value of cos 90 equal to 0 it is. 0 of anything also 0. So, dot product of perpendicular vectors equal to 0, that is. Next, scalar product is negative. When it is negative, if theta is greater than 90 and less than 180 degree. In between 90 and 180 the value of theta have, then cos function will be negative. Cos function negative means scalar product also negative that. Next, here take about these unit vectors. Here I dot I equal to j dot j equal to k dot k equal to 1. Here can take I cap dot I cap, that is equal to magnitude of I cap equal, it is a unit vector, I cap is, this is also unit vector, its magnitude is 1. Next, its magnitude also 1. Both vectors are acting in the same direction, I cap and I cap means, so here take cos 0, this value equal to 1, because of cos 0 value 1, 1 of anything, 1 into 1, that is equal to 1 only. Next to j cap dot j cap, similar way you can take j cap dot j cap, 1 magnitude, next 1 magnitude and cos 0, this is equal to 1 only. Next to k cap dot k cap, similar way you can take k cap dot k cap, that is equal to 1 into cos 0, this value equal to 1 only that. Next here I cap dot j cap, we will see I cap dot j cap. Here these two vectors are perpendicular to each other, I cap and j cap. Magnitude of this unit vector is 1, magnitude of another unit vector also 1. Both vectors are perpendicular. So, write here cos 90, the value of cos 90 equal to 0. So, write here 1 of 0, that is equal to 0. Similar way j cap dot k cap, both also orthogonal vectors are perpendicular vectors. So, its dot product equal to 0, and k cap dot I cap also, both are orthogonal vectors or perpendicular vectors. So, its dot product equal to 0 that. Next, in case of orthogonal unit vectors, here that is equal to dot product equal to 0 it is. Next, in terms of components of vectors, we will see if a bar equal to ax I cap plus ay j cap plus az k cap, b bar equal to, this is not minus beta, here equal to bx I cap by j cap plus bz k cap. Here dot product of these two vectors, just calculation observe that. Here a bar dot b bar, here two vectors are given ax I cap, ay j cap, az k cap, and b bar given as a bx I cap, by j cap and bz k cap. A bar dot b bar, that is equal to ax I cap plus ay j cap plus az k cap dot. Here b bar vector can take bx I cap plus by j cap plus bz k cap. Now it's a dot product you are taking, beta. First here see ax I cap dot bx I cap. You can take, these are magnitude, ax is the magnitude and bx also magnitude. First multiply the magnitudes, ax into bx. That is I cap dot I cap can write. It is the method to solving questions also. Next, ax I cap by j cap, ax into by. Here take I cap dot j cap. Next, third term also multiply plus ax bz of I cap dot k cap it is. With first vector, first component along x direction component multiplied with this total b bar vector. Next, with the second component multiply plus ay and bx. Here j cap dot I cap. Here j cap and here I cap. Next, plus ay by j cap dot j cap plus ay bz j cap dot k cap. Again also three terms get with second term ay j cap multiplied with the total this b bar vector. Just general multiplication like taking, but here dot we will maintain here because of it is a dot product. Next, az k cap plus az into bx. Here take I cap dot, sorry, k cap dot I cap. Next, plus az by k cap dot j cap. Next, plus az bz k cap dot k cap. In these 9 terms also, if you are observe, here I cap dot I cap have. Next, here j cap dot j cap have. Here k cap dot k cap have. Except these 3 terms, remaining 6 terms if you are observe, I dot j, here I dot k, orthogonal vectors, orthogonal unit vectors, j dot I, j dot k, k dot I, k dot j. So these terms are 0, it is 0, this term also 0, this term also 0, and this term also 0, and it is 0, it is also 0, because of dot product of orthogonal unit vectors they have, their dot product equal to 0, remaining I dot I 1. So here just I am writing ax bx, I dot I equal to 1. Next, ay by plus ay by plus az bz it is. This value az bz, k dot k equal to 1 it is. So we get. That's why generally dot product of any two vectors require directly you can multiply magnitudes of ax into bx, ay into by, az into bz. Just components of I cap multiply and j cap multiply and k cap magnitudes just multiply that. Then we'll get directly the answer is. Next, a bar dot a bar. For given vector a bar dot a bar you are taking ax into ax, ay into ay, az into az. We'll get ax square plus ay square plus az. The component of a bar perpendicular to b bar in the same plane. Actually previous point is the component is along the direction of the vector. The component of a bar along the b bar, but here perpendicular to the b bar, that the component of a bar perpendicular to b bar in the same plane, that here c bar equal to a bar minus a bar dot b cap into b bar have. For this, here a bar vector can take, it is the b bar vector can take, angle between A bar and B bar is theta. Angle between the vectors A bar and B bar take theta. One component of A bar along the direction of B bar acting, A cos theta it is. One more component acting normal to that, normal to this A cos theta, it is A sin theta actually. They are asking the component of A bar perpendicular to B bar in the same plane, means this A sin theta component is normal to the B bar and in the same plane also have, that is they are asking. Here can write A bar vector can take A bar equal to A cos theta. A cos theta. It is acting along the direction of B bar. So it is multiplied with the unit vector B cap. Why multiplying with B cap means so A cos theta acting along the direction of B bar vector. So it is multiplied with the unit vector B cap plus A sin theta. It is unknown direction have normal to that. It is multiplied with the n cap. I will take here n cap it is. From this A sin theta n cap, that is equal to right A bar minus here A sin theta n cap equal to A sin theta n cap equal to A bar minus this term can take A cos theta into B cap. Just write because of require here A sin theta n cap normal component. Then here A sin theta n cap, that is equal to here A bar minus A cos theta. A cos theta. The previous one derived that A cos theta. Here A cos theta equal to A bar dot B cap into B cap. Here A cos theta equal to, otherwise you can take A bar dot B bar also that. A bar dot B bar equal to AB cos theta. From this write A cos theta equal to A bar dot B bar upon B. This is can take A bar dot B cap also. So A cos theta equal to A bar dot B cap into B cap it is. It is a perpendicular component of component of A bar vector perpendicular to the B bar vector in the same plane. It is a proof. How to derive this equation means this is the method. Next, the component of B bar perpendicular to A bar in the same plane. Component of B bar perpendicular to A bar in the same plane is, that is D bar, just denoting that here B bar minus B bar dot A cap into A cap. Similar way you can do the derivation for it also. Here but just I will give the diagrammatical representation. It is a B bar vector taken, it is a A bar vector can take, but component of B bar normal to the A, this direction B cos theta acting, because of angle between A bar and B bar theta can take. Here normal to that A bar, this is B sin theta into n cap. They are asking B sin theta into n cap that. Here B sin theta into n cap, that is equal to, take here B bar minus B bar minus B cos theta into A cap will get. So from this write B bar minus B cos theta. B cos theta equal to what you write? A bar dot B bar by A. So here take A cap, otherwise B bar dot A cap into A cap it is. That is the proof also for this. Next one more property, modulus of A bar plus B bar, it's mean magnitude of A bar plus B bar. Generally we will write the expression for magnitude of A bar plus B bar means this vector form you are taking, there take under root A square plus B square plus 2AB cos theta, writing this is. Actually, dot product of the self vector will give square of its magnitude. Here can take A bar dot A bar, A bar dot A bar, dot product of the self vector will give square of its magnitude. A square can take as A bar dot A bar also. Otherwise, if you have a doubt, A bar dot A bar can take, that is A into cos 0. So, here write A square into cos 0 value 1. So, write A square it is. Similar way, B bar dot B bar, B cos 0, B square can write. So, B square place can take as a B bar dot B bar it is. Next to plus, here 2AB cos theta have, here take as a bar dot B bar plus A bar dot B bar, or B bar dot A bar also can take, no problem. Now, A bar dot B bar means AB cos theta, it is also AB cos theta. How many times repeated? 2 times repeated. Then we will get this equation. So, that is why here write A bar plus B bar equal to under root A bar dot A bar plus B bar dot B bar plus A bar dot B bar plus B bar dot A bar can write. Here A bar dot A bar equal to A square, B bar dot B bar equal to B square, A bar dot B bar plus B bar dot A bar. According to commutative law, A bar dot B bar equal to B bar dot A bar. So, 2 A bar dot B bar can write. 2 A bar dot B bar means A bar dot B bar equal to AB cos theta can write. So, 2 AB cos theta can take. Next, examples of dot product. What are the examples for the dot product means? Work can take. Work means the dot product of, in lower classes generally saying the product of force and displacement. But in the 11th class saying as a statement is the dot product of force and displacement will give the work. Next, power. Power also the dot product of force and velocity will give as a power. Next, flux. Here it is a magnetic flux, B bar dot A bar taken. Electric flux means C bar dot A bar can take. These are the examples for that. Next, work done by a force. It is a force vector. When the displace the body from a point, this is one position given, to another point, another position given that. So, initial position denoted with that R bar, R1 bar otherwise. R1 bar equal to 3I cap plus 4J cap plus 6K cap. Generally you understood. Here one coordinate is given 3, 4, 6. 3 x coordinate, 4 y coordinate, 6 is the z coordinate. So, I write x coordinate means that coordinate is multiplied with a unit vector. Next, y coordinate is multiplied with a unit vector. Unit vector along the y direction j cap. Here z coordinate is 6. That 6 is multiplied with a unit vector along the z axis k cap it is. Next, second vector is second position R2 bar can take. R2 bar equal to similar way. Here x, y, z. X component multiply with unit vector I cap, y coordinate multiply with unit vector j cap, z multiply with unit vector k cap, 5k cap it is. Now, 2 vectors we get, but work done means what you take? Dot product of force and displacement. Force vector is given here, but displacement required. It is the initial position of the body and it is the final position of the body. Displacement equal to final position minus initial position. So, displacement R bar equal to R2 bar minus R1 bar. So, take here R2 bar 7I cap plus 2J cap plus 5K cap minus R1 bar minus 3I cap minus 4J cap minus 6K cap it is. Now, both vectors also just I substitute, but here R1 all are positive, but here have the negative. So, I multiplied. Here 7I cap minus 3I cap, 4I cap can take. 2J cap minus 4J cap minus 2J cap can take. 5K cap minus 6K cap minus K cap can take. It is a position vector, but work required. So, work done equal to dot product of force and displacement F bar dot R bar or F bar dot S bar also can take. Here R also displacement will give, otherwise S bar also, generally displacement denoted with that S. So here writing F bar dot S bar, otherwise R bar also can take. Here work equal to dot product force vector can take 2I cap minus J cap minus 5K cap dot here R bar equal to take 4I cap minus 2J cap minus K cap. Now dot product means what you take, multiply the magnitudes of unit vectors I cap and J cap and K cap. Here 2 magnitude have, here magnitude 4, 2 into 4, 8. Only I cap magnitudes multiply. In case I cap is multiplied with the J cap, that is 0, because of dot product of the orthogonal unit vectors will give 0 that. Here minus 1 have, here minus 2, minus of minus plus 1 into 2, 2 only that. Next minus, here minus, minus of minus plus 5 into 1, take 5 it is. This value is 15 units. 15 units it is. It is the method to calculate. So fourth option is correct for the question is. Next here one more question, see. A force F bar equal to 3I cap plus Cj cap plus 2K cap Newton acting on a particle causes a displacement S bar for minus 4I cap plus 2J cap minus 3K cap given. If the work done is 6 joule, the value of C is, here work done also given 6 joule. All are given in a SI units only. So take here work done equal to dot product F bar dot S bar can take. Here work given as a 6. Force vector can take 3I cap plus Cj cap plus 2K cap dot. Here displacement can take minus 4I cap plus 2J cap minus 3K cap. Now 6 equal to, here 3 and minus 4 minus 12, here C and here 2 plus 2C, here plus 2 minus 3 minus 6, plus of minus only can take, minus 2 into 3 6. Here 6 have, this 6 also can take, 6 plus 6 12, this minus 12, here can take plus 12 equal to 2C. It is a 24 upon 2 equal to C. So the value of C equal to 12 it is. That is the value of C. It is a method to calculate that.